In this video, we'll cover section 2.2, quadratic functions. We're going to start looking at two forms of the quadratic equation, and the first one, we're going to refer to it as the general form. So we have here A represents the coefficient of the x squared term. And so if A is positive, meaning greater than 0, then we say the parabola will open upward. If A, the coefficient of the x squared, is negative, that means less than 0, we will say the parabola will open downward. Okay, so if we have a parabola that opens up, then the vertex will be the minimum point. And if we have a parabola that opens down, the vertex becomes the maximum point. Also, one thing that you should always pay attention to is that not all parabolas are symmetric with respect to the y-axis. The only ones that are symmetric with respect to the y-axis will be if the x-coordinate of its vertex is equal to 0. However, the one that we have here is still symmetric, not with respect to the y-axis, but with respect to this line. And the equation of that line, well, first of all, we call that axis of symmetry, and the equation of that line will be given by the x-coordinate of the vertex, okay? So this will be given x equals to a number, and that will be the x-coordinate of the vertex. And we're going to see some examples in a minute. Okay, so what I want you to write down here is that parabolas are going to be shaped. I don't really agree with this, but that's what the book says. Like folds or inverted. And we're just going to repeat what I said previously. If the coefficient of x squared is positive, the parabola will open up. And if the coefficient of x squared is negative, the parabola will open down. And so I like to make reference to positive people. They're usually smiling, right? And then negative people are usually frowning, right? Yes? Most people. All right. So now, like I said, we're going to look at two different forms of the quadratic function. So two different forms. This one is called the general form. And now on the next slide, we're going to take a look at the standard form. So standard form is what you guys see here. And that form, it is pretty useful when you're trying to find the vertex. And that is because that will give you what the horizontal and the vertical shifting was. And so in this case, H represents the horizontal shifting, and K represents the vertical shift. So if we look at the definition here, for this equation, we have f of x is equal to a times x minus h, close parentheses, square, plus k. Now we have here that a cannot equal to 0. Why do you guys think we have that? Very nice, exactly. If this was a 0, then that x squared will be 0, right? So then we will just have f of x will equal k. And what type of function will that be? Say it. constant function, right? Because k is just representing a number. So yes, that's why it's important we say a is not zero. Very nice, Chris and Peru. So we call that the standard form. And so the vertex is going to be the point h comma k. Now, just like we know that horizontal shifting or translations are counterintuitive, when we get to the vertex, we're also going to consider that. And keep in mind that the formula, the standard form, has a negative already in it. So that's another reason why we will consider the opposite number while finding the vertex. So just like I was mentioning earlier, the parabola is going to be symmetric with respect to the line. And in this case, we're talking about a vertical line. And that will be the line x equals to a number. And of course, that number will come from the x coordinate of the vertex. All right? And it's going to be a vertical line. And that is the, let's just write it down here, the axis of symmetry. So the type of questions you can expect on the test, maybe I will ask you find the vertex of the parabola, but I could also ask you find the axis of symmetry of the parabola. Or I could ask you find the maximum point. If the parabola is opening down, you know the maximum point will be the vertex. Or I could ask you find the minimum point. If the parabola is opening up, then the minimum point will be the vertex as well. Okay, so it is important to understand all those relationships. And of course the vocabulary. Okay, so we have here two cases again. If A is positive, greater than 0, the parabola will open upward. If A is negative, less than 0, the parabola will open downward. And we could see here the same thing that I was talking about, the axis of symmetry. We'll have the x-coordinate, we will use the x-coordinate of the vertex. All right, so let's go to the next slide. Do you guys have any questions? Yes. Is it an emergency? Okay, we'll take a break, like in 10 minutes? Yeah? If you really need to go, you could go. Okay. I just don't want you to miss all the fun. Okay, so we're going to be graphing a few quadratic functions. And so here's a list that could help you out while you're doing your homework. And so first, you need to determine if the parabola is going to be opening upward or downward. And we already know how to identify that, right? So let's look at A. In this case, will be outside the parentheses. It would still be the coefficient of x squared. So in this case, for our first step, we notice that A is equal to -2. And so we know that -2 is less than 0, or in other words, meaning -2 is negative, right? So then the parabola will be opening down or downward. Okay, so we took care of the first step. Now, step number 2, we need to determine where the vertex is located at. So we know that the vertex is given by h comma k. And so in this case, the vertex will be, remember the negative is part of the formula. So the vertex will be given by 3, 8. So just like we do with horizontal shifting, we always think like counterintuitive. So if you see a -3 here, then the vertex will have a +3. Now for the y-coordinate of the vertex, we take the same number given here. So that will be 8. So let's go ahead and plot the vertex. So that will be at 3, 8. So that will be there. And now, remember how we covered complex numbers before this section, right? And I told you we need to cover this because certain polynomials don't have x-intercepts, right? They still have zeros. They may just be imaginary. And so if this parabola, we already know it's going to open down, right? So will this have zeros, I mean X-intercepts. Yes, right? It's going to be something like that. So yes, we don't know how wide it is going to be yet. So yeah, we know it will have real zeros, which graphically will look as X-intercepts. But if this parabola was opening up like that, then it wouldn't have intercepts, right? The intercepts will, no intercepts, but we say the zeros are imaginary, okay? We will encounter one of those pretty soon. So let me erase that. So in this case, we know we are going to have X-intercepts, and I mentioned that because that will be our next step here. And so to find any X-intercepts, it says here to solve by solving f of x equals 0. Another way to say that will be to let y equal 0 and solve for x. And that is true for any type of function that has X-intercepts. You let the other variable equal 0. Yes?
Same as finding the zeros, right?
Yes, finding the zeros. X-intercepts. And solve for x. X-intercepts, they are pretty much the same, but X-intercepts will be actually on the x-axis, and then zeros could be real or imaginary.
Can we use the function on zeros? Would that be the same, or is that also different?
Oh, great question. On the test, I need to see your steps. You may use the calculator to check your answer. You're always welcome to do that, but I need to see your work. So we're going to do what is being set there. So for the function f of x, I'm going to turn that into y is equal to -2. Well, let's do this first. X-intercepts. Do you guys think we're going to have 1 or 2? I say 2, yes. So, like I was saying, we're going to let y equal 0, and then we're going to solve for x. So we already know that the y coordinate will be 0, right? Because it's on the x-axis, so it makes sense that the y coordinate is 0. So let's go ahead and write the equation. So instead of f of x, or instead of y, I'm going to substitute that with a 0. And then we're going to solve for x. So first we take care of this plus 8. It is adding on the right side. So if I move it to the left side, it will be subtracting. Now we have -2, which is multiplying everything inside the parentheses, right? There's no sign in between them. So because of that, we're going to divide by -2. And we keep the negative sign. Now here, -8 divided by -2 is equal to +4. And here, we need to undo the square, right? So what is the inverse operation of squaring? Square root, right? So we take the square root on both sides, and of course that will take care of squaring, so that will be just x minus 3. Now, however, here for the square root of 4, we're going to use both roots, positive and negative, because we know that 2 squared is equal to 4, and so is -2 squared, right? -2 times -2, so that is equal to +4. So because of that, we take both roots, and that will be plus minus 2. Now from here, we have we are going to have two equations. One with a +2 and one with a -2. So +2 is equal to x minus 3, and -2 is equal to x minus 3. So I'm going to tell you what not to do, okay? Well, first I'm going to tell you what to do. So we're solving for x. So we have 2 the negative 3 is subtracting to the x, so if I move it across, it will be adding. So 2 plus 3 is 5. Okay, and then you get all excited, and this is what not to do, okay? You get all excited, and you don't do the work here, and you just say x is equal to negative 5. Will that be okay? No, not at all. And believe it or not, it happens very, very often. So this is wrong, okay? So let's see. We have found one of the x-intercepts so far. That is 5, 0. So what we need to do is actually solve the equation. So we'll have negative 2. Again, the negative 3 is subtracting, so we add 3, and that is equal to x. 3 minus 2 is 1. So that has nothing to do with negative 5, right? Nothing, nothing. Okay, so that means our next x-intercept is 1, 0. So let's go ahead and plot those 2 points, 1, 0, and then 5, 0. So if the question was find the zeros, then we will just say x equals 5 and x is equal to 1. Okay, Chris? So find the zeros. Those will be the zeros. The intercepts will be points. From here, just a little preview. I don't know if you guys remember this from Algebra 2. Could we find the factors? So what if we move this one with the x? What would it be doing? It has a implied positive, right? So it will be minus, right? That will be one factor. The other factor will be x minus 1. So we're going to be doing a lot of this in Chapter 2. Going from zeros to factors to, or intercepts, factors, zeros, whatever. Okay. So now let's just find the y-intercept. And so for the y-intercept, it says here on our table, find the y-intercept by computing f of 0. So in other words, what they're telling us is to let x equal to 0, and then find or solve for y. And now would it be okay for me to say, let's find the y-intercepts in plural? Only one, right? Because we're talking about a quadratic function, and if we had more than one y-intercept, then it wouldn't be a function, yes. So I forgot what the equation was. Okay, so the equation is f of x is equal to negative 2x minus 3 squared plus 8. And then another reason I do not just accept your answer with the calculator is because you will find yourself at a point in your life, maybe you don't think that will happen, but you might encounter a professor that will not allow you to use calculators. And that is true. It is a reality. It happened to me. I took about 3 classes without a calculator. And then, oh, we actually have Robert here. Robert, can you use the calculator in your calculus class?
Non-graphing, non-spreadsheet, something else.
Yeah. So for that reason, I mean, we found a little loophole there. We're not going to talk about it. But
I have a question about that loophole.
there are other professors that will not let you use calculator at all. I took engineering physics at UTEP. I couldn't use a calculator, not even a scientific one, not even a 4-function calculator. We had to do everything by hand. And you might be thinking, oh, well, I'm not going to take engineering physics. You don't know. You don't know what you're going to be taking. You might change your plans, your major in the future. Okay? So that's why I need you guys to learn to do everything by hand. Another thing, if you are taking a class, a higher level class, whether physics, math, engineering, whatever it is, computer science, if you have a problem that requires for you to find the intercepts or the zeros or the roots of an equation, your professor is not going to wait for you to take out your calculator to find them. They'll probably make fun of you. Really. They will make fun of you. Okay? So that's why. All right, anyways, going back to finding the Y-intercepts. Oops, intercept, right? Only one. All right, after we're done graphing this, we'll go take a break. So we say we're going to let x equals 0 and then solve for y. Or as the book states it, we're going to find f of 0. Same thing, right? We substitute every 0 with every x with a 0. So -2 parentheses 0 for this x here, -3 squared plus 8. And we do first what's inside the parentheses. So 0 minus 3 is -3 squared plus 8. Should I multiply -2 times -3?
No.
No. First we do the square. So that will be -3 squared, that is positive 9. And then we multiply, should I add 9 plus 8? No. First we multiply. So -2 times 9 is -18 plus 8. And so that will be -10. So that tells me that the y-intercept will be the point 0 for x, comma, -10.
What's the last one?
Okay, so now going back to the steps, the very last step is, of course, to plot the intercepts, the vertex, any additional points as necessary, and then we connect them with a smooth curve, not with lines, because if we connect them with straight lines, what kind of function would it look like? What? The what? Absolute value, yes. So it has to be like a curve. Oh, it's so pretty. Okay, so we're going to pause the video. Let's go take a break, and then we'll come back. We're going to move on to example number 2, which is another quadratic function, and it is also written in standard form. So the first step, we need to evaluate if the function will open upward or downward. And so we see that the number outside the parentheses to the left side, which represents the coefficient of x squared, is, what is that number? I don't see any numbers, so what do we know it is?
1.
A 1, right? And so we say that a is equal to 1, and so 1 is, of course, greater than 0, meaning it is positive. So that tells us that the parabola will be opening outward. Okay, number 2, we need to find the vertex. So the vertex, it is given by the numbers representing h and k. And in this case, those numbers, you guys see how we have here a +3. So just like we do with horizontal shifting, we take the opposite of that number, and that will be -3. For the y-coordinate of the vertex, it will be the same number that you see there, and that is a +1, or a +1. Now, if you're still not sure why, keep in mind that the standard form has that negative in it, and so if we have negative times -3, that is how the function has the x plus 3 squared. So that still means that the coordinate for h will be -3. All right? Okay, now we need to find the x-intercepts. That's step number 3. So let's go ahead and plot the vertex. So that will be -3, 1. That's there. And we're saying the parabola is going to open up, right? So is this going to have x-intercepts?
No.
No, it's not going to have x-intercepts. It can have, it will have zeros. They're just going to be imaginary. But x-intercepts, no, it will not have x-intercepts.
So do we just skip the steps?
You still need to show me. So we follow the same guidelines for x-intercepts. And so we said that we will let y equal 0 or f of x equal 0, and then so for x. And here you can see clearly the positive 1, we'll have to subtract 1 or move it to the left side. That will make it negative 1. And so in this case, to eliminate the square, we take the square root, right? The square root takes care of the square. It cancels because they're inverse operations. So we have x plus 3 is equal to the square root of negative 1. So what is the square root of negative 1? I. Now in this case, we're going to take both the positive and the negative square root of negative 1. So we will say positive and negative I. And that is x plus 3. Now from here, we create two equations. And so it will be I is equal to x plus 3. And negative I is equal to x plus 3 as well. Now, since we're just talking about x-intercepts, at this point here, we will say no real solutions. Because we cannot take the square root of negative 1, therefore we won't have x-intercepts. Because x-intercepts have to be composed of real numbers. Yes?
That's the answer right there?
Yes, you will stop right here. If the question is to find the x-intercepts. If the question was to find the zeros, and I'm just doing a preview of the next section, then you will continue solving it using imaginary numbers. So from here, just to finish this, it will be x will equal to negative 3 plus I. If you notice, I'm writing it in standard form. Remember, standard form has the real part first and then the imaginary part. The other one will be x is equal to negative 3 minus I. Now, what can you guys tell me about these two numbers? Negative 3 plus I and negative 3 minus I. Not inverses. Conjugates, yes, complex conjugates. So complex conjugates, whenever you get that for your imaginary zeros, complex conjugates always come in pairs, always. So sometimes we might get to a problem where I give you one of the zeros, so then you should know that the complex conjugate is also another 0, all right? But we'll look into those problems next section. Okay, let's go ahead and find the Y-intercept. And so for the Y-intercept, remember we let x equal to 0. In other words, we're finding f of 0. And so that will be 0 plus 3 squared plus 1. So we do what's inside of the parentheses first. That 0 plus 3 is 3. So 3 squared plus 1. 3 squared is equal to 9. 9 plus 1 is equal to 10. So the y-intercept will have the coordinates 0, positive 10. So let's go ahead and plot that point here. Now, what if I ask you, what is the axis of symmetry here? So it is a vertical line, right? So we know it's x equals to a number, and where do we get that number from? The vertex. The x-coordinate or the y-coordinate? The x-coordinate. So x equals negative 3. So I'm just going to trace it here. And so if the graph is symmetric with respect to that line, how many units do you count from that axis of symmetry to the y-intercept? 3 units, right? So what that means is that we should have another point, 3 units to the other side from the axis of symmetry. And I know that for my math lab, 2 points are enough for you to graph a parabola. However, on paper, I think you need more than 2. 3 is better. So that's how you can get an extra point Another way to get a point, of course, you could use, in this case, you may use your calculator to find another point, or you could pick a random value for x and then find the y, you know, you could do things like that. All right, so we're going to move on to the general form of the quadratic function, and the way that you find the, well, let's, the quadratic equation, or quadratic formula, that's what it's called, right? Quadratic formula. Okay, so we know it is negative b plus minus the square root of b squared minus 4ac, and everything is divided by 2a. So for the vertex, what we're going to do is find negative b over 2a. That will be the x-coordinate of the vertex. And so that one, in case you forget, it comes from here, from the quadratic formula. Let's do negative b over 2a. So we have negative b over 2a. That gives you the x-coordinate of the vertex. Now, since we're talking about a function, we know the definition of a function is that for every x, there is one what? One what? There's a y, right? So for every input, there's an output. And so what we do here, I know that it might look a little weird here, but what we're going to do is once we get a number here, we're going to get a number from here. Once we get that number, we're going to substitute that number into the function to find the y value that corresponds to that x value. All right? So I know the formula looks a little weird, but it's not very difficult to use. Okay, so let's go ahead and get to the example. So let's go to the next slide. And now we're going to graph something that it is in general form. And so step one is very similar to step one when you graph in standard form. And so that you need to determine if the parabola will open up or down. Now we have our function here. This is a function we're going to be using. And so we're going to determine the coefficient. So a is going to be the coefficient of the x squared term, so that's negative 1. B is going to be the coefficient of the x term, which is negative 2. And C is the coefficient, the constant term, the number. So that is equal to 1. Now, one thing I do not want you to do, it makes me very angry, is when students do this. Like they just write on top, A, B, C. And why? Because they tend to overlook the signs. And I've graded so many exams, and I've seen it so many times, and I know one of you or two of you or three of you are going to do it. Please just take the time to write them down. Okay? Yes.
Well, which kind of what you meant by they just put E.
They just write like A, B, C here on top, and then like they sometimes consider A to be positive 1, or they forget that B is actually negative 2 and not positive 2, you know? Okay. So yeah, if you're confused, don't do it. Okay, so is this parabola, we know that A is negative, so we know it's going to open downward, right? Right, so we got the first step out of the way. Now, second step, when you have it in standard form like we did previously, it's very easy to find the vertex. When they are in general form, it's not so easy. We actually have to work for that. And we're going to be using that formula. So number 2 is the vertex. Okay, so for the vertex, we use the formula, let me just write it here. Negative b over 2a, and then we find, once we find that, we substitute that into the function. Okay, so negative, and then what is b? Negative 2.
More than negative.
Everything divided by 2 times a. What is a? Negative 1. Okay, so here we have negative times a negative, that's positive, so positive 2. And then 2 times negative 1 is negative 2. So what is 2 divided by negative 2? Negative 1. Okay. So now, so far, we have found that the x-coordinate is negative 1. Now, like we said, for every x, there is a y. And so we're going to substitute that number into the function. So now we need to find what is f of negative 1. And so we have the equation here. So we have a negative outside the x squared. And then we substitute negative 1 inside parentheses. And then we square it. And then we have minus 2 times negative 1 plus 1. Now, if you want to use your calculator for something like this, I'm fine, but you still need to show me your substitution. Okay? On the test. To do it by hand, first we do what's inside the parentheses. So negative 1 squared would turn into positive 1. Negative 2 times negative 1, that's positive 2 plus 1. And then we will have negative 1 plus 2 plus 1. Negative 1 and positive 1 are opposite, so we say they cancel. They turn into a 0, and we have only 2 left. So from here, I get the vertex will be negative 1 comma positive 2, because 2 is the function value at x equals negative 1. So let's go ahead and plot that on our graph. Negative 1 comma 2. And then we said that it's going to open down, so are we going to have x-intercepts? Yes. How many?
When they're reaching.
If you had any parabola that has the vertex at the origin, that could be considered to just have 1. Or if you have a parabola that, for example, is like this, like that, that could also be 1 y-intercept, or something like this. So yes, parabolas could have 1 x-intercept, 2 x-intercepts, or no x-intercepts. Could they have more than 2? No. Why not? Because what, Miguel? A whole different equation, right? What were you saying, Sean? It doesn't have too many turning points, right? So we're actually going to go over turning points. And how many turning points does a parabola have? Only 1, right? So depending on the degree of your function, what is the degree of a parabola or a quadratic function? The degree will be the highest exponent. 2. So depending on the degree, you could only have 1 less turning point. So parabolas have 1 turning point. If it was a cubic function, how many turning points could we have? 2 turning points, or 3 x-intercepts.
What's the one that's like sine x?
Those can have an infinite amount of x-intercepts because they just keep repeating. We'll cover those next semester. You're not going to like them that much, just so you know. Okay, what else are we doing? Oh, yeah, the y-intercept, right? No, the x-intercepts. Let's do the y-intercept because it's so easy. I really like it. So if we read this part, find the y-intercept by computing f of 0. And then you guys notice here it says that we're going to get that point, right? So according to our C value, our constant value, that is 1, right? So I'm going to predict that my y-intercept is going to be here. It's going to be the point 0, 1 here. Now let's see why that is true. So again, we let x equal to 0 and find y, or in other words, we find f of 0. So going back to the parabola, we have, to the equation, we have negative and then 0 square minus 2 times 0 plus 1. So in this case, what is 0 square? 0. And what is 0 times negative? Still 0. What is negative 2 times 0? 0. So what are we left with? 1. So that's why it makes sense that when you have a quadratic function written in general form, to find the y-intercept, you could just look at that constant term, and that's it. So that's probably a step you could skip on the test, and I wouldn't have a problem with that. All right, now let's find the x-intercepts. And again, for the x-intercepts, we are going to let y equal to 0, or f of x equal to 0. Oh, I forgot to do this. So x-intercepts. And we already established we're going to have 2 of those, right? By the way, when you enter your answers on my math lab, make sure you put spaces between your number. It's like number, comma, space, number, close parentheses, comma, space, parentheses.
Yes, I hate it when I think I learned answer.
I know, but actually if you think about it, that's how English is written too. Like you put a space after a comma, always. Or after a period, 2 spaces. So you're learning some grammar too. Okay, so the function was something like negative x squared, what else? Plus 1. Okay, now let's see. Could we factor this? Yeah?
Are you asking us?
Yeah, I'm asking you this. Okay, let's try. How about if we multiply the whole thing by negative 1? Could we do that?
Yeah.
Yes. As long as we do it to both sides. Yes. What is 0 times negative 1? Still 0. Still 0. What is negative x squared times negative 1? X squared. What is negative 2 times negative 1? Positive 2x. And what is positive 1 times negative 1? Negative 1. Now let's see if we could factor this one. So it will have to be x, x. Since this sign is negative, that means that our signs in between the factors will be 1 of each. And then we have the only factors of 1 are 1 and 1. However, if we check our work by multiplying the 1s on the outside, we will get x times negative 1 is negative x, and then positive 1 times x will be positive x. So what will happen there? They cancel out, right? So we wouldn't have any x terms. So that what that tells me is that we cannot factor it. So what does that mean?
Yeah.
And don't say use your calculator. I'm serious. What is that other thing that we could use besides a calculator, of course? Your brain, of course. So how about the quadratic formula?
That's like the one formula.
Negative b plus minus square root b squared minus 4ac divided by 2a. So I guess this step was kind of useless, right? To multiply by negative 1. What was this? Positive 1? Okay. All right, so remember how I told you I want you to write this down. A is equal to -1, B is equal to -2, and C is equal to +1. So now I'm going to go ahead and substitute all those numbers here where the B is, where B, A, C, and A. All right? So let's do it. So X will be equal to negative from the formula, and then we have that B is also negative, so it's -2. And then we have plus minus square root of B squared, so that's -2 inside parentheses, please. Some of you are still not using parentheses. Then we have -4. A is substituted with -1, and then C is substituted with +1. Everything divided by 2 times A, and A is equal to -1. Okay, so negative, that will give me +2, plus minus. Now I'm going to do the operation inside the radical, so -2 squared is +4. And then we multiply -4 times -1, that's +4. +4 times 1 is still +4. Everything divided by 2 times -1 is -2. Now I need to add the two numbers inside the radical, so 4 plus 4 is 8. Divided by -2. Now here, would it be okay for me to simplify by dividing 2 over -2 and then 8 divided by -2?
Yeah.
No, it's not okay. I know it's very tempting, but we can't do that. What we need to do is simplify the radicand, what's inside, by factoring it. And so in this case, we choose 2 factors where one of them is a perfect square, so we can take the square roots, and that will be 4 times 2. Still divided by -2. Then we take the square root of 4. What will be the square root of 4? 2, right? So once you take the square root, that number comes out of the radical. Okay, don't leave it inside. The one that will stay inside is this 2 here. Everything is being divided by -2. Okay, now from here we have 2 equations. One of them will be x equals to 2 plus minus 2 square root of 2. And if you notice, everything is being divided by -2. So I'm just going to split the fraction, say 2 divided by -2, and then the other quantity divided by -2. So this will be simplified. 2 divided by -2, what is that? -1. And then now, the only 2 numbers that you divide are here, not inside the radical. Headphones? So we have 2 divided by -2, and that will be, oh, I haven't even split the fraction, right? I mean, not the fraction, but the 2 equations. Okay, let's just do this. So that will be 2 divided by -2 will be -1, right? We still need to consider the plus minus. So that will be 1 times the square root of 2. Now from here, let's get the 2 solutions. One of them will be -1 plus the square root of 2, and the other one will be -1 minus the square root of 2. Now, someone who has a calculator available, handy? No one? So So to graph them, we need to get an approximation, right? Because, well, actually, I know how. This is 1.41 minus 1, so this should be 0.41. And then this is 1.41, so that would be minus 2.41. Let's see if I'm right, Jonathan. You know what? The square root of 2 is a very famous irrational number. I used to have to prove in college why it was irrational, so I just know. Is it true? Okay.
Is it 0.41 or
0.41, da 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 da, like it has a non-terminating decimal. Okay. So that tells us, I'm about to let you guys go, just hold on, that the X-intercepts will be at 0.41, comma 0, and the other one will be at negative 2.41, comma 0. I still have 1 minute. So 2.41, comma 0. Oh, negative, sorry. So somewhere here. And the other one was 0.41, right?
Yeah.
Somewhere here. And then, of course, we trace them. And then it will look like that. Okay? So that will be the last problem. You're welcome to pack your things now and go.